projects. In this video, we are going to explain about the project title, an intrusion detection feature selection method based on improved mutual information. Introduction. Intrusion detection data often contains numerous features that are high dimensional and redundant. The project centers on the challenge of efficiently selecting the most relevant features from this complex data set. The aim is to shift through this abundance of data and identify the crucial elements for effective intrusion detection. The project introduces a novel intrusion detection framework that leverages improved mutual information. This framework incorporates the CCMI feature selection algorithm, which is designed to optimize subsets of features. The focus is on refining the selection process to enhance the efficiency of intrusion detection systems. The primary goal of the CCMI feature selection algorithm is to enhance the classification rate and accuracy of intrusion detection techniques that employ machine learning. By optimizing feature subsets based on improved mutual information, the algorithm aims to improve the overall performance of intrusion detection system. The project conducts a comparison between the newly proposed feature selection method and 3 existing methods. This comparison likely aims to evaluate the efficacy and superiority of the proposed approach against established techniques, showcasing its potential advancement in selecting relevant features for intrusion detection. Objective of the project. The primary goal is to create a more potent and efficient method for selecting features within intrusion detection systems. This specialized approach aims to shift through complex data to pinpoint the most relevant elements crucial for identifying potential network intrusions. Leveraging improved mutual information and novel algorithms, the project seeks to enhance the accuracy and precision of intrusion detection system IDS. By using more refined and effective feature selection techniques, the goal is to improve the system's ability to accurately identify and categorize different types of network intrusion. The project acknowledges the challenges posed by high dimensional and unbalanced network traffic data. To overcome these hurdles, the project aims to design a feature selection framework that can effectively navigate through this intricate data landscape, ensuring that relevant information crucial for network intrusion detection is identified efficiently. Ultimately, the overarching objective is to optimize the performance of intrusion detection systems. This involves ensuring that these systems can effectively identify and respond to network intrusions with increased accuracy while reducing the computational burden, thereby improving overall efficiency in detecting and addressing potential threats. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This initial step involves importing various libraries and packages essential for data handling, visualization, machine learning, and web framework setup. These packages include Pandas for data manipulation, Matplotlib and Seaborn for visualization, scikit-learn for machine learning algorithms, Keras for deep learning functionality, Flask for web framework, and SQLite for database management. Exploring the dataset, NSL-KDD. This phase involves an in-depth exploration of the NSL-KDD dataset, which is used for intrusion detection. It includes examining the dataset structure, identifying columns, understanding data types, and obtaining initial statistical insights like mean, median, and standard deviation. This exploration aids in understanding the data's characteristics and potential pre-processing needs. Data processing. In this phase, the dataset is processed to prepare it for analysis. This includes converting the raw data into a Pandas data frame, utilizing Keras processing methods to handle data, or formatting it for neural networks if applicable. Additionally, Unwanted or irrelevant columns are dropped to streamline the dataset, making it suitable for further analysis. Visualization using Seaborn and Matplotlib. Utilizing visualization libraries like Seaborn and Matplotlib to create visual representations of the dataset. This step involves generating various types of plots such as histograms, bar charts, scatter plots, or heat maps to explore data distributions, correlations, and patterns, aiding in gaining insights into the dataset's characteristics. Label encoding using label encoder. Categorical data often requires conversion into numerical format for machine learning algorithms to process. Label encoding using scikit-learn's label encoder is employed to transform categorical data into a numerical format, making it suitable for machine learning models. Feature selection. This module involves selecting the most relevant features from the dataset. It comprises analyzing the entire set of features and utilizing techniques like select percentile with mutual info classify to choose the most significant features. This step aims to reduce dimensionality while retaining the most informative features for intrusion detection. Splitting the data to X and Y for machine learning. After pre-processing and feature selection, the dataset is split into predictor variables X and target variable Y. This partitioning is crucial for machine learning, where X represents input features and Y represents the output to predict. Building the model. This phase involves constructing various machine learning models such as random forest, XGBoost, KNN, MLP. These models are built and trained using both the original dataset and the feature selected subset to evaluate their performance in intrusion detection. Training the model. The models are trained using the prepared dataset, and the performance metrics like accuracy, precision, recall are assessed to compare their effectiveness in identifying network intrusion. Flash framework with SQLite for sign up and sign in. This involves setting up a web application using the Flash framework along with the SQLite database. It facilitates user sign up and sign in functionalities, providing a platform for user interaction. User gives input has feature values. Users input feature values through the front-end interface. These inputs undergo pre-processing steps similar to those applied to the dataset, ensuring they are properly formatted for prediction by the trained machine learning models. Trained model is used for prediction. The trained models are used to predict outcomes based on the pre-processed user inputs. Each model generates its prediction or confidence score for the given input. Final outcome is displayed through front end. The final prediction outcomes or result are displayed through the front end of the application. Users can view the intrusion detection results based on their inputs, providing insights into potential network intrusion based on the model's predictions. Algorithms used to implement this project, we have utilized the following algorithms. The first algorithm is random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and aggregates their output to make predictions. Random forest is used for intrusion detection by analyzing network traffic data. It evaluates various features simultaneously to identify potential intrusions, leveraging the collective decision making of multiple trees. XGBoost, extreme gradient boosting. XGBoost is a gradient boosting algorithm known for its speed and performance. It builds multiple decision trees sequentially, refining predictions based on prior model's error. XGBoost is employed to enhance the accuracy of intrusion detection. It iteratively improves upon previous model's shortcomings, leading to more precise identification of network intrusion. KNN, K nearest neighbor. KNN is a straightforward algorithm used for classification by identifying an object's classification based on the majority class of its neighboring data points in feature space. KNN categorizes network traffic instances into intrusion categories by measuring similarity with neighboring instances. It considers the proximity of instances to classify potential intrusions. MLP, multi-layer perceptron. MLP is a type of neural network composed of multiple layers of interconnected nodes, capable of learning intricate patterns and relationships within data. MLP is utilized to capture complex relationships in network data. By processing data through interconnected nodes, it identifies intricate patterns of potential intrusions, leveraging its ability to discern nonlinear relationships. We have built these algorithms along with original data as well as with CCMI features. Now we will discuss each algorithm with CCMI feature. So the first one is random forest. Random forest with CCMI feature. Random forest is an ensemble learning method constructing multiple decision trees during training. With CCMI features, it still creates multiple trees independently on selected features, then combines their outputs for improved accuracy. In the context of intrusion detection with CCMI features, random forest utilizes the selected features to identify potential intrusions. By leveraging these chosen features, it makes collective decisions from multiple trees, enhancing the detection accuracy while focusing on the most relevant attributes. XGBoost with CCMI feature. XGBoost is a boosting algorithm that sequentially builds decision trees focusing on correcting errors made by previous models. With CCMI features, it continues to refine predictions and improve accuracy through iterative learning on the selected attributes. Utilizing CCMI features, XGBoost improves intrusion detection accuracy by continuously enhancing models based on the selected features. It iteratively learns from these chosen attributes, refining its predictions to better identify network intrusions. KNN with CCMI feature. KNN categorizes objects based on the majority class of the neighboring data points in the feature space. With CCMI features, it operates by identifying intrusion categories using the proximity of instances in the selected attribute space. In intrusion detection using CCMI features, KNN relies on the selected attributes to classify potential intrusions based on the proximity of instances in the reduced feature space, contributing to a more focused and efficient classification process. MLP with CCMI feature. MLP, a neural network model with interconnected layers, is adept at capturing complex relationships in data. With CCMI features, it continues to analyze intricate patterns within the selected attributes to identify potential intrusions. When applied to intrusion detection with CCMI features, MLP utilizes the chosen attributes to comprehend complex relationships within the reduced feature set. It excels at recognizing nonlinear patterns in network traffic data, aiding in the detection of sophisticated intrusion patterns. These algorithms, when paired with CCMI selected features, focus on leveraging the most relevant attributes to improve the accuracy and efficiency of intrusion detection. By incorporating the reduced and more informative feature set obtained through CCMI, these algorithms aim to enhance the detection capabilities and robustness of the intrusion detection system. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Comparison graph. Comparison graphs offer a visual breakdown of how a model performs across essential evaluation metrics. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis we have accuracy score and on the y-axis we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis, we have precision score, and on the y-axis, we have algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positive plus false positive. This is the recall comparison graph. On the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis, we have FN score, and on the y-axis, we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, this localhost, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. Here we need to enter all these details to register. But I have already registered, so click on sign in. Here we need to enter the username and the password which we have created, and then click on sign in button. We have logged in successfully. So here we need to enter all these parameters to predict whether attack is detected or not. Before entering the parameters, let us understand the parameters first. So the first one is service. It denotes the type of network service being used. Example HTTP, FTP for categorizing network traffic. Flag represents control bits in TCP headers indicating connection status. Example SYN, ACK to understand network connection behavior. SRC bytes measures the number of bytes sent from the source, indicating the volume of outgoing data. Destination bytes indicates the number of bytes received at the destination, reflecting the volume of incoming data. Count tracks the frequency of observed connections with similar attributes in the network traffic. Error rate, source error rate, shows the percentage of connections with SYN errors signifying connection issues. Same SRV rate, same service rate, portion of connections using the same service among total connections, aiding in service-based analysis. Different SRV rate, Different service rate, portion of connections using different service among total connections, assisting in diversified service analysis. Different host SRV count, different host service count counts instances with different services among hosts, indicating service variety per host. DST host same SRV rate, destination host with the same server rate, DST host different SRV rate, destination host with the different server rate, DST host server rate, destination host with the server rate. So now we will enter these parameters. So I'm entering the parameters now. So here we have entered all the parameters. Now click on predict button. So here we can see we got the result. There is no attack detected. It is normal. Now we will enter another set of parameters. So click on home. So I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on predict button. So here we can see the result. There is an attack detected. Attack type is U2R. Now we will enter another set of parameters. Click on home. So I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on predict button. So here we can see we got the result. There is an attack detected. Attack type is R2L. Now we will enter another set of parameters and check whether attack is detected or not. So I'm entering the parameters now. So here I have entered another set of parameters. Now click on predict button. So here we can see we got the result. There is an attack detected. Attack type is probe. Now we will enter another set of parameters and check whether attack is detected or not. So I'm entering another set of parameters now. So here I have entered another set of parameters. Now click on predict button. So here we can see we got the result. There is an attack detected. Attack type is DDoS, distributed denial of service. In this way, by entering the parameters, we can predict whether attack is detected or not. Now click on sign out button. The conclusion of the project: existing intrusion detection methods face challenges due to inadequate feature selection. This limitation results in inefficiencies when handling complex network data, leading to inaccuracies in identifying and addressing network intrusions effectively. Ineffective feature selection can lead to an overload of irrelevant or noisy data, making it challenging for intrusion detection systems to accurately identify potential threats. This weakness can compromise the overall effectiveness of the system in securing networks. The project pioneers a novel framework utilizing enhanced mutual information and the CCMI feature selection based on correlation and conditional mutual information algorithm. This framework optimizes feature subsets to enhance the performance of intrusion detection systems. By integrating advanced mutual information techniques and the CCMI algorithm, the project aims to identify and select the most relevant features from complex network data. This optimization process is crucial for enhancing the accuracy and efficiency of intrusion detection systems, ensuring they focus on the most critical attributes for threat detection. Rigorous experiments conducted on the NSL KDD dataset involve 4 classifiers and show significant improvements in various performance metrics such as accuracy, precision, and error metrics. The experiments serve as empirical evidence showcasing the effectiveness of the proposed framework. The observed enhancements in accuracy and precision highlight the framework's capability to more accurately identify and categorize network intrusions compared to methods lacking robust feature selection techniques. The proposed framework exhibits superior performance compared to existing methods. It demonstrates higher accuracy in intrusion detection while requiring fewer features and reduced feature selection time. This superiority in accuracy, combined with the reduced need for extensive feature and quicker feature selection, signifies the practical effectiveness and efficiency of the project's framework. It highlights its potential for real-time deployment in securing network against intrusions more effectively than existing methods.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.